Question 17 and question 12 talk about the application of the law of conservation of mechanical energy to solve problems. The law of conservation of mechanical energy states that the energy can neither be created nor destroyed, only transferred from one place to another or from one shape to another. Now, the total mechanical energy of the system remains constant. So, the initial kinetic and potential of the initial kinetic energy and potential energy of the system before something happens is equal to the final kinetic energy and potential energy of the system after that event happens. Question: which of the following statements correctly gives the law of conservation of energy? Energy can neither be created nor destroyed, only transferred from one shape to another. In this lesson, we talked about the pendulum and what kind of energy does the pendulum have at each position, and how energy converts from potential to kinetic and vice versa as it travels between the points. The diagram shows or indicates the instantaneous position of a simple pendulum in simple harmonic motion. At which positions is the potential energy of the system maximum? Now, the potential energy of this pendulum is maximum when it is further from the ground or from the bottom point. So at point A and point C, the pendulum will have the maximum potential energy. So here we'll have maximum potential energy and here as well we will have maximum gravitational potential energy. At point B, the system will have maximum kinetic energy. The law of conservation of mechanical energy states that the sum of the system's kinetic and potential energy before an event is equal to the sum of the kinetic energy and potential energy after the event. Which of the following or which equation is best describes or expresses this law? Well, the sum of potential and kinetic energy at the beginning equals to the sum of the kinetic and potential after the event has happened. The figure shows a coconut of mass m falling from a height h to the ground. Which equation is correct for the kinetic and potential energies of the coconut at point A, B, and C? At point A, the coconut is the furthest from the ground, and hence it will have maximum potential energy. And because it's standing still, it will have no kinetic energy. As the coconut falls down and reaches point B, it is closer to the ground, so it will have less potential energy. And because it started moving and accelerating, it will have a higher velocity here, so it will have higher kinetic energy. When it reaches the ground at point C, it reaches the reference level, so it is at a height 0 from the reference level, and hence there is no potential energy. But because just before it hits the ground it has the highest speed, it will have maximum kinetic energy. So if you look at the blue column, that represents the amount of gravitational potential energy that this coconut has, you'll see that the gravitational potential energy decreases as the object falls down because the height decreases. At the same time, as the object falls down, its speed increases because it's accelerating down. So the kinetic energy of the object will increase. So point C here that says the kinetic energy at C is bigger than that at B, bigger than that at A is the correct one. This question we solved at class says the illustration below shows a box on a curved frictionless track. The box starts with a zero velocity, so there's no initial kinetic energy here. It then slides from the top of the track to the horizontal part of the ground, at the ground right here. If the velocity just when it reaches the ground is 15 meters per second, so this is the final velocity, 15 meters per second indicates that it has a final kinetic energy. What is the height h from the ground to the top of the track? So he wants me to find the initial height that this box has moved from. In this case, all of the initial potential energy, all of the initial gravitational potential energy that this box contained due to its height turned into kinetic energy at the end. All of the initial gravitational potential energy turns into final kinetic energy. So this amount right here is the same amount right here. All of the initial kinetic energy, all of the initial potential energy will be burned and turned into final kinetic energy. Since there's no initial kinetic here and no final potential here, the equation reduces to GPE initial equals to KE final. Now, since he wants me to find the height, I need to substitute the equations of both energies. To find the gravitational potential energy, I multiply mgh. Since this is the initial gravitational potential energy, we are multiplying mgh initial is equal to Ke final, which is half mass V final squared. Now, since we have mass on both sides of the equation, we can cancel the mass. The equation reduces to GH initial equals half V final squared. And then you substitute to find H. G is 9.8, H is the unknown, equals half the final velocity given in the question is 15. Don't forget the squared. Using the shift solve on the calculator, 9.8 times x equals to half multiplied by 15 squared. Shift calc and then equal. So you can see that the initial height is 11.4 meters. So initial height is 11.47, which is 11.5 meters. Similarly, this question is solved the same way. It says a ball is released at the top of a smooth inclined plane, 0.6 meters above the ground, as shown in the figure. What is the velocity of the ball when it reaches the bottom of the inclined plane? At the beginning, here, the ball had gravitational potential energy because it's above the ground. So, because the ball is lifted above the ground, or to be more exact, 0.6 meters above the ground, it has initial gravitational potential energy. After the ball is released, it will lose height, so the GPE will decrease, and at the same time, its speed increases. When its speed increases, the kinetic energy of the ball increases. just like you saw in the animation in the PowerPoint. So GPE will decrease and the KE will increase until the final kinetic energy is equal to the initial potential energy. So according to the equation, GPE initial equals to KE final. We substitute the equation for each one of them and find and solve for the velocity. It says what is the velocity of the ball when it reaches the bottom of the incline, so he wants me to find the final velocity. GPE can be found by multiplying mgh, and KE can be found by multiplying half mass velocity squared. Now, because mass is in both sides of the equation, we can cancel the mass. Left is GH, which is 9.8 times the height 0.6 equals half نزل النص times the velocity squared. The unknown is the velocity, so you use the shift solve on the calculator to find it. 9.8 times 0.6 equals to 1/2 multiplied by x squared, and then shift calc equal. So the speed of the ball as it reaches the end of the incline is 3.43. The final velocity is 3.43 meters per second. Here are some other questions that you can see to solve. You have this question right here, which is what happens to the total energy of the pendulum. Remember that the total energy is the same as the mechanical energy, it stays the same. Here, when the cart goes from point B to point C, its height decreases, so the GPE decreases, and at the same time, its speed increases, so its kinetic energy increases. And this question we solved in class. How much is the velocity of the rock just before it hits the ground? Same way that we found for the box and for the ball. This one also solved in class, which is match each point with the correct energy bar.